In this section, we are going to talk about the derivative of a composite function. Now, if you think back to your algebra or pre-calculus class, a composite function is when you have a function within a function. Okay, an example of that, let's say we have f of x equals to x squared plus 3x minus 4, then we can call this g of x because g of x is within another function. And then what's happening is, so we can rewrite f of x as g of x raised to the fifth power. So what we're doing is we're taking this function and raising it to the fifth. So this is an example of a composite function of whose derivative we'll take. And we're going to take this derivative using something called the chain rule. So here are the steps, and I'll go through this example with you. So we're going to let u equal to whatever the inner function is. So the inner function is x squared plus 3x minus 4. So we're going to let u equal to x squared plus 3x minus 4. Now we're going to rewrite the original function f of x, but now in terms of u. So instead of saying x squared plus 3x minus 4 to the fifth, this whole thing is equal to u. So we're going to say u to the fifth. So instead of saying g of x to the fifth, to simplify this, we're going to call this function equal to u. That's going to be u to the fifth. All right, now step 3, we have to find u prime. So the derivative of u, which is x squared plus 3x minus 4, is going to be 2x plus 3. Okay, now the chain rule states that if you have a function within a function, then the derivative of that is going to be the derivative of u to the fifth. So whatever this function is, the derivative of that times u prime. So the additional step is always to multiply by the derivative of the inner function, which is u prime. So the derivative of u to the fifth is going to be 5u to the fourth. The 5 comes down, subtract 1. That's just the basic power rule of derivatives. And then u prime is going to be 2x plus 3. And then we can do a substitution again to bring back the original function. So since u is equal to x squared plus 3x minus 4, we have 5 times the quantity x squared plus 3x minus 4 to the fourth times 2x plus 3. Now this is kind of a long way of doing it. As you get better and better at these, you don't have to do the u substitution. So for example, one way to do it, the other way to do it rather, we have x squared plus 3x minus 4 and raised to the fifth. This is f of x. So when we take f prime of x, we just take the derivative like we normally would. So the 5 comes down. So we have 5, and then this doesn't change, right? So it'll be x squared plus 3x minus 4. And we subtract an exponent because, I'm sorry, I need a new pen. We subtract an exponent because of the power rule, so this becomes 4. But the one thing you have to keep in mind is when the parentheses contains a function as well, we have to multiply this by the derivative of the inner function. That's going to be 2x plus 3. Now, you can do it either way. You can do it the way using u substitution, or if you get it, you can just do it this way. It's entirely up to you. This is the shortcut. This u substitution method is kind of the longer way, but it's more step by step. So let's do this one. 2 different ways. Let's first do it using u substitution, and then I'll do the same thing without u substitution. So we have f of x equals to 4 times negative 6x to the fourth plus 6x to the 10th. This here is the inner function, so we're going to let that be u. So u is equal to negative 6x to the fourth plus 6x to the 10th. So I'm going to rewrite this as 4, and then this whole thing is u. So I'm going to rewrite that as 4u to the 18th. Now, u prime is going to be the derivative of u, which is going to be negative 24x cubed plus 60x to the 9th. If I take f prime of x, I would multiply 18 times 4, which is 72. I subtract 1 from the exponent, so that's 72u to the 17th. But anytime we substitute with u, you have to have a u prime. And then now we can just plug everything back. U is negative 6x to the fourth plus 6x to the 10th. So we plug that back in. And then u prime is negative 24x cubed plus 60x to the 9th. We plug that back in. So this is using u substitution. If you don't want to do it this way, here's what you can do. You can say 18 times 4 is 72. and we subtract 1. So that gives us this 72 negative 6x to the 4th plus 6x to the 10 to the 17th. The parentheses does not change. All that does is that the exponent comes down and we subtract 1. Then we multiply that by the derivative of the parentheses, which is going to be negative 24x to the 3rd plus 60x to the 9th. So anytime you have an inner function within an exponent, always multiply by its derivative. Here's another example. We have 3 times the square root of 5x to the 9th plus 8x to the 7th plus 5. Now the first thing we're going to do is we're going to do u substitution. So we're going to let u equal to this inner function right here. Okay, now we're going to have f of x equals to 3 times, instead of square root of this function, it's going to be square root of u. And remember, before we take the derivative, we have to convert any roots into exponential rational exponents. So radical u is going to be 3u to the 1/2 because we have an exponent of 1 and a root of 2. So this is going to be 3u to the 1/2. Now, if I take the derivative of that, well, first of all, I got to get u prime. So that's going to be 45x to the 8th plus 7 times 8 is 56x to the 6th. That's our standard power rule for derivatives. And now if I take f prime of x, the 1/2 comes down and multiplies with the 3. So this gives you 3/2. And then you have u to the 1/2 minus 1. So we just subtract the exponent. Now 1/2 minus 1, if you get a common denominator, the 1 turns into a 2 over 2. This gives you a negative 1/2. Now, because we have a negative 1/2, this goes to the denominator and becomes positive 1/2, which is the same thing as square root of u. But then you always have to multiply by u prime. Anytime there is an inner function that we use for substitution with u, you have to multiply by u prime, which we calculated here. So now we have 3/2 times radical u, which is 5x to the 9th plus 8x to the 7th plus 5 times u prime. And you could have done all this instead of u. You could have written this whole thing out over and over again, but I think u just makes it a little bit easier to do the work. Okay, now let's take the derivative of trigonometric functions using the chain rule. So we have f of x equals to sine of x to the 5th. Now sine of x has a derivative of cosine, but not if it's x to the 5th, right? It's only if it's sine of x. So what we're going to do is we're going to let u equal to x to the 5th. And now I'm going to rewrite this as f of x equals to sine of u. Then, when I take the derivative of f, so f prime, sorry, u prime, if u is x to the 5th, u prime is going to be 5x to the 4th. Now, if I take the derivative of f prime of x, then it's going, so the derivative of sine is cosine, so we get cosine of u. But anytime you have an inner function, we always have to multiply by u prime. Now u is x to the 5th, so we have cosine of x to the 5th, and then u prime is going to be 5x to the 4th. So if you were doing this without u substitution, all you would say is the derivative of sine is cosine, and the parentheses never changes, so it's cosine of x to the 5th. But because we have an inner function, we have to multiply by its derivative, which is 5x to the 4th. Now this is different than part B, which says sine x to the 5th power. So when you see this, this is actually equal to sine of x to the 5th power. When you have sine 5th x, that's sine of x to the 5th power. So now in the parentheses, our inner function is going to be this. It's going to be sine of x. That's our inner function. So we're going to let u equals to sine of x. So now we have f of x equals to u to the 5th. And then u prime is going to be the derivative of sine, which is the inner function. That'll be cos x. So if I take f prime of x, the 5 comes down, so you have 5u to the 4th. But anytime you do u substitution, you always have to multiply by u prime. Now u is sine of x, so we get 5 sine x to the 4th, which you could write as sine 4th x, times the derivative of sine, which is going to be cosine of x, and that'll be your u prime. If you were to do it without using u substitution, you would do something like this. You would say the 5 comes down, so we end up with 5 times sine of x to the 4th power, but because we have an inner function, we have to multiply by the derivative of that, which is going to be cosine of x, and then we get the exact same answer. Some people like the shortcut, some people like u substitution. You figure out whatever is going to work for you. Here's another example. We have 1 over 5x minus 2 to the third power. We want to find f prime of x. So we have this inner function 5x minus 2, and we're going to let that equal to u. So u is equal to 5x minus 2. So we're going to rewrite f of x as 1 over u to the third. Now remember, for derivatives, we always rewrite this whole thing with the exponent at the top, at the numerator. So we're going to move it to the numerator. It becomes u to the negative third. Now, anytime you have a u, you're always going to get a u prime. Anytime you do that substitution, you'll always get a u prime. So u prime is going to be the derivative of 5x minus 2, which is just 5. Okay, so now I take the negative 3 down, so I have negative 3u to the negative fourth times u prime. U is equal to 5x minus 2, but I'm not going to substitute that yet. I'm going to make this positive by moving it to the denominator. So I have negative 3 over u to the fourth times u prime. Now I can plug in u and u prime, and then negative 3 times 5 is negative 15. So this becomes my final answer. So once again, you might have questions on this, and that's great. So just come to class prepared with them. Next, we have f of x equals to cosine of x squared plus 3x minus 5. So we're going to let u equal to x squared plus 3x minus 5, which is always going to be this inner function. And I'm going to rewrite this as cosine of u. Now, the derivative of cosine is going to be negative sine. So I'm going to say f prime of x is equal to negative sine of u. But anytime you have u and not x, we always have a u prime as well when you do that substitution. So u is x squared plus 3x minus 5, and u prime is 2x plus 3. The 2 comes down and you have a 3. So if I plug these back in, we get negative sine of x squared plus 3x minus 5 times 2x plus 3. If you do this without the shortcut, you would just say cosine has a derivative of sine or negative sine. The parentheses never changes. But because we have an inner function, we just have to multiply by the derivative of that, which is going to be 2x plus 3. And you can use that as a shortcut. All right, now here's another one, which is going to be the product rule. So now we have two different inner functions. We have u and we have v. So we're going to say u is 4x squared plus 4 and v is 8x squared minus 3. And we're going to let f of x equals to u to the 5th times v to the 11th. All right, so now let's use the product rule. So the product rule says that u prime, well, first of all, u prime is going to be 8x and v prime is going to be 16x. And because we're taking a product of two different things, we're going to call this a and we're going to call that b. So the product rule states that when you have a product of two things and you take this derivative, it's going to be b times a prime plus a times b prime. So we have to list out what all those are. Okay, so on the side, I'm going to say a is u to the 5th, and a prime is going to be 5u to the 4th times u prime. Anytime you take the derivative of u, you always get that u prime. B is v to the 11th, so b prime is going to be 11v to the 10th. The 11 comes down, and then you have that times v prime. So here are our u prime and our v prime. So now let's just plug everything in. Our derivative f prime of x is going to be b, which is v to the 11th, times a prime, which is 5u to the 4th times u prime, plus a, which is u to the 5th, times b prime, which is here 11v to the 10th times v prime. And now I just plug everything back in. So I know what v is, it's up here. I know what u is, that's here. I know u prime is 8x, so I have to have that. And then I have my u to the 5th. So u is over here, 4x squared plus 4. So that's u to the 5th. Plus 11 times my v to the 10th times my v prime. And then you can multiply like 5 and 8x because they're both on the outside of the parentheses. That gives you 40x. You can multiply 11 times 16x. That gives you 176x. Now again, this was a lot of steps, but just make sure you copy these down and then come to class prepared with any questions, and I'd be more than happy to answer those for you. These next ones I will do in the next video.